Hello my friend, today we are going to talk about recursive function. What is recursive function? It is just a function that invokes itself inside its body. What does it mean? It means that if you have a function like this, you just type factorial of, for example, 4 here. It means, yes, this is recursive function now because, hey, this function invokes itself inside its body. The problem is that when we invoke it now, it will never stop, right? Because, hey, we are invoking a function inside this another function. There is no way to stop it. It's gonna invoke forever, right? And well, we can show it, right? Look at this. We can show the number like this outside. And you will notice that we have got what? Always 4. And it's just gonna repeat itself. And well, how do we stop a function like this from invoking itself? We need to make a condition somehow, right? We need to make a condition, but firstly we need to change the number to something else, because if you make a condition like this, if number is equal to, for example, 4, then stop. So we will stop it by returning something static, something that will stop the function. We have finally something that is gonna be returned, right? Then we have got just what? 5 and 0, which is the 5 that is sent here. It's 5. And then we invoke the factorial of 4, and because 4 is equal to 4, we returned 0. But we can do something like this. If number, we can invoke number minus 1. And this time we can do something like, for example, if number is equal to 0, then we'll stop. And you will notice that we have numbers like 5, 4, 3, 2, 1, 0, right? If we do here, for example, 50, we'll have numbers starting from 50 up to 0, because we stopped invoking the function when we when the computer met the condition like this. Okay, and the question is, how are we going to use it in a real life programming situation, not just for counting numbers from 50 to 0? Let's look at our factorial program from the last lecture. Well, at the sample here. Notice that factorial of 5 is really what? Is really a factorial of 4 multiplied by 5. Because, well, this thing is really factorial of 4, so we can like paste it here, right? So it's really like this. So to be honest, it's really something like that. Factorial of 5 is really equal to factorial of what? Of 4, right? Because really this sign here is really, well, is really a function, right? Multiplied by 5. Factorial of 4 is really what? Factorial of 3 multiplied by 4, which is factorial of 4, 4 minus 1, right? Which is 3, multiplied by 4, and so on, right? 3 is equal to 2 multiplied by 3, which is 3, 3, 3. 3 minus 1 is, of course, 2. Here is 3, right? But notice that this number here is just 1 lower. And we can use it. We can use it here by doing something like this. Let's return the factorial of n minus 1 multiplied by n. And if the number here is 1, let's return 1. And now notice something. We have got what? If we type here 5, right? Then we have got factorial of 5 minus 1, which is 4, multiplied by 5. So this is this situation, right? Factorial of 5 is gonna invoke a function inside itself, like factorial of 4, and then we multiply by 5 here. And then again, it's gonna invoke itself until there is a situation where the number is here gonna be equal to 1, and then it will be 1 finally. I think the cool way to imagine it a bit better is to do something like this. Let's copy this into the program, and then imagine that we have got here what, 5. So if 5 is equal to 1, this is not true, then 5 minus 1 multiplied by 5. And let's copy it here. Okay, so this changes into what? Into this. Well, without this. And now we have got what? This is 4. This is not gonna be returned because this is not true. So let's copy it here. And to be honest, our program, our computer doesn't know what is factorial of 5 now, right? He needs to invoke factorial of 4 to find out what to return. He doesn't know now. So this factorial of 4 function would look like this. If 4 minus 1, which is 3, multiplied by 4, right? So like this. And we've got it like this. And then what happens? We have got what? 3, 3, 2, 3. And it goes like this. And then we have got what? 2, 2, 1, 2. And we have got something like this. And finally we have got what? 1, 1, and here is 0 and here is 1, but because this is true, firstly, this is not gonna be returned. 1 is gonna be returned. We finally stopped invoking function inside another function. So here we have got finally a result, right? So you have got finally a situation where we have got here 1. And this number, that 1 here, is gonna go where? It's gonna go here, right? To here. And you have got what? 1 multiplied by 2 is 2. And then that value is going to go here. So factorial of 2 was 2, and we have got 2 multiplied by 3 is 6. And this goes here. 6 multiplied by 4 is 24, and this goes here. And 24 multiplied by 5 is 120. And that's all, right? We have finished the invocation of all the functions from the last. So notice that in order to really return the value at the start, our computer doesn't know, right? The value here. He can't do it. That's why he needs to invoke function inside itself again, until there is a time when there is a function that returns the value that is no longer gonna be returned from another function, right? So the static value like this, for example, 1. And then our computer computes, it calculates every function from the last to the first one. And that's why we have a solution like here, right? Okay, let's go back to how it looked like. So as I said at the beginning, recursive function is a function that invokes itself inside its body, but you need to always remember about condition that stops executing a function inside another function. Otherwise you have got something like almost infinite loop, right? But the problem is that, loop is just executing instruction after another instruction. In the recursive function, you will not get a result that you want until you get the value from the last execution, right? So that doesn't mean that it's fast. Iterations are faster than recursion. So the question is, where should you use recursive function? Well, there are situations like, for example, when you are looking at folders, right? Because inside a folder there is another folder, and there can be another folder, then can be a file that you are looking for, and you can search inside folders using recursive functions, and this is the best way to do it. So this is not something that is not useful, right? This is pretty useful, but not for things that will have too many levels of going inside. Up to, for example, 10, 15, okay, that's pretty cool. But when you go like 50, 100 levels inside, then that's not a good idea to use recursive functions, right? That's all in that lesson. Thank you very much.